while I'm erasing, remember we had this notion of an argument, a valid argument, and a sound argument back from the chapter on reasoning and fallacies. And we're going to hit that stuff again in this chapter. A valid argument is one where if the premises are true, the conclusion follows as a matter of logic. A sound argument is one where if the premises are true, the conclusion follows as a matter of logic, and the premises are in fact true in the real world. Okay. All right, so somebody want to just call out some complicated proposition and we'll evaluate a truth table for it? I'm going to make something up. I could do this one. This is what is that? Okay, here is the question here is to write a proposition that is logically equivalent to the following. Not, open paren, Q implies P, close paren, or, open paren, not Q or, not Q. 1, 2, 3, 4, and open paren, not R implies not P. Oops, not P is in paren. Sorry?
We have to turn a paper this way.
Turn the paper that way, yeah. Sorry. Implies not P, 1, 2, 3, or open paren, not open, not R, open paren, not open, not R, or not R, or not R, close. 2, 3, 4, 5. Okay. I don't even know if the parentheses balance. Can somebody tell me? Okay. This is horrible. I mean, it's horribly complex, but it actually isn't hard. All right? Not R or not R. That simplifies, doesn't it? What is it? Not R. Not R. R. Okay, so all this stuff out to there already reduces to R. Yeah? Okay. Am I even going to be able to tell where these parentheses are supposed to be? Okay. We've got not, R implies not P. Okay, the assignment here is to get rid of the if-thens and turn this into something that just involves and, or, and not. So R implies not P is logically equivalent to not R or not P. Okay, so this is not R or not P. Okay, but we are now negating that. How do you negate a conjunction? A disjunction, sorry.
How is that not R, not P?
P implies Q is logically equivalent to not P or Q. Okay, so R implies not P is logically equivalent to not R or not P. Yep. Okay, we're now negating this, right?
It's not R and not P.
Okay, so this negation is applying to both of these guys. We're negating this or this, which is not this and not this. Okay, so this is, that evaluates to R and P. Okay? So this whole thing here becomes R and P. Okay, so you have R and P or R. What does that evaluate to? This is only true if both R and P are true. This is true whenever R is true. So for this to be true, this has to be true. Right? And so this whole thing is just logically equivalent to R all by itself. In order for this to be true, both R and P have to be true. But if R is true, this is true. And if this is true, this whole thing is true whether P is true or false, because you've got it true on the right-hand side. Is that okay? So this reduces to R.